My name is Brian Adler, and I'm a professional services architect at RightScale. And in that capacity, I've had the opportunity to work with a lot of our customers, a lot of them enterprise and otherwise, and to assist them in building highly available fault-tolerant applications in the cloud. And so what we're going to talk about today is sort of some of those best tips and tricks that we've accumulated in best practices around architecting for both high availability and multi-cloud environments. And we'll talk a little bit about what we mean by multi-cloud environment and why that may or may not be a good idea. The agenda I want to kind of go through is just sort of some terminology and level setting. I want to make sure that we're all using the same words for the same things. And as we get through this, you'll see why we're going to digress into that a little bit. Then the second thing I want to talk about is takeaways, and that's more of you, the audience, takeaways. It's sort of the things that I want to make sure that I convey to you and sort of the goals that I have for you guys at the end of this presentation. Talk a little bit about designing for failure and what that means and how you can try to design around that. A little bit more definitions on cloud and components, because there's different clouds and each cloud has different components and abstractions, etc. So we want to make sure that, again, we're kind of level set on what those terms mean and how they all play together. And then we'll get into the meat, which is some reference architectures and the options you have within those reference architectures for building highly available applications. And we'll talk about sort of the best practices of stitching all those pieces together. And then we'll have some sort of wrap up, and then hopefully we'll have time for questions and answers. When I did this yesterday, it took about 45 minutes, so we should have at least 5 or 10 minutes at the end for questions. Okay? Okay, so terminology, a couple things I just want to define or describe. The first one's not so much a definition as more of a description, but fault tolerance. Any design that is basically built such that if something fails, it can keep running, right? You have redundancy and replication built in so that you don't go down, right? You might be degraded, but at least you're still up and running in some way, shape, or form, okay? And then high availability, or HA, you'll hear me use those interchangeably through the presentation, but basically that's the yardstick or the metric, if you will, that fault-tolerant applications and fault-tolerant systems are measured on, right? Basically your availability score, if you will, is how fault-tolerant you essentially are. And people always talk about the nines. You've been heard it today, people talking about 3 nines and 5 nines, and for example, Amazon's S3 SLA is 11 nines, something ridiculous like that. Well, what does that really mean? Well, just to give you kind of a breakdown, we sort of broke down what that math really means. So for example, 5 nines means just over 5 minutes of downtime per year. Now the very important thing to note about that is that's not just not just unplanned, but planned as well. So it's not just when Amazon US East goes down. It's also when you guys need to push out a new version of code or add a new feature to your platform or something. That always counts against your availability score as well. So it's important to factor that into your application design, to try to find ways to push out those new features and push out those new versions without bringing everything down. That can be challenging, but generally most applications have some mechanism that you can implement that with. And then lastly, DR, or disaster recovery. I'll just read this and we'll talk a little bit about that, but process, policies, and procedures related to restoring critical systems after a catastrophic event. Basically, when the you-know-what hits the fan, the ability to get yourself up and running somewhere else, right? That's your disaster recovery plan and policy, if you will, okay? So we'll talk a little bit about what that really means in terms of high availability and multi-cloud environments as we work through the rest of the presentation, okay? So the takeaways, the things I want to try to make sure that you guys get out of this. We'll introduce some architectural options for building these HA fault-tolerant applications. And then we'll talk about the best practices in stitching these together. Here's all these components, here's all these options we've got. How can I best put these together in a different environments to try to promote the availability of my overall application? And we'll talk about multi-AZ. I assume most of the audience is probably familiar with some of these terms, but we'll define them again in a minute if you're not. We'll talk about multi-availability zone, multi-region, and multi-cloud. And we'll talk again about the architectural options within them, where they coincide and where they do not, where they diverge. And then the pros and cons of each of these options, okay? Again, the best practices about what your options are depending on the cloud you may be in. Okay, designing for failure. And we say designing for failure in a good way. Obviously, we're not hoping things fail, but we want to make sure that we design around a failure, right? You heard Michael mention it this morning, but Werner Vogel's comment about everything fails all the time, right? You need to be prepared for that, or do the best you can to be prepared for that. Large-scale failures in the cloud, they don't happen often, but as we all saw on April 21st, they do happen, right? And I'll give Amazon all the credit in the world, is that we've kind of become complacent as a result. So as I said, on April 21st, that kind of proved to us that these large-scale failures can happen, right? And we became complacent. A lot of folks were, Amazon's just done such a tremendous job, they assumed that those kinds of things weren't going to happen. And now we're all painfully aware that they can. And in the last 2 months, we've had a lot of requests about exactly this topic. So it's a very timely thing that we're all here discussing it. Important point to note, the application owner is ultimately responsible for the availability and the recoverability of that application. Again, the infrastructure provider is going to provide you that infrastructure within an SLA, and they're going to do their best to meet that SLA. But as we all know, and we've all seen, they don't always meet that. And what do? They give you some credit. Well, that credit is wonderful, but it didn't help the fact that your app was down, right? So you, the application owner, are ultimately responsible for making sure that it is up, okay? And you hear this next bullet point repeated multiple times. It's always a balance between the cost, the complexity, and the risk, right? How risky is this thing to happen? If it's very likely, then regardless of the cost, I should probably find a way around it. If it's super unlikely, well, and it's really expensive, maybe I'm willing to take that risk, right? So it's an insurance policy. Basically, how much money am I willing to spend for something I hope I never need, right? So it's always a constant trade-off there. The nice thing is that the cloud infrastructure that we now have has made these HA and disaster recovery efforts, incredibly affordable, right? Multi-server, multi-AZ, multi-region, multi-cloud. You can spin these things up in minutes and pay pennies for them, right? Never before in history have we had that opportunity, right? So let's try to find ways to take advantage of that, okay? What do we mean by cloud when we talk about cloud? It means a lot of different things to a lot of different people, right? To us, a cloud is a physical data center entity behind an API endpoint, right? Somewhere, for example, let's use AWS US East. Somewhere there's a physical data center, and most of us know it's in Northern Virginia. I don't know where in Northern Virginia, not a lot of people do know. We know it's in Northern Virginia, but that doesn't really matter, right? I don't really care where it is. All that I care is that I know the general region it is, so if a hurricane goes up, goes up the East Coast and all of Northern Virginia loses power, then I know I'm probably going to lose AWS US East. But it's exactly where it is, I don't care. What I do care about is that I have API access to get to those resources, right? So what do we really mean? AWS, that's not a cloud, right? That's the services they provide around that. EC2, even though it stands for Elastic Compute Cloud, we don't really think of it as a cloud because, again, it's sort of the overarching infrastructure around the cloud offerings. Eucalyptus, folks just talked here, cloud.com, OpenStack, none of those are clouds either, right? Those are cloud technology providers. But when we get down to an example such as EC2 US East or US West or the EU or the two Asia Pacific regions, or you have My Private Cloud running on cloud.com or Eucalyptus or Rackspace, those are clouds, right? Those are physical data centers somewhere that you can access via an API, all right? Last point there is the AZ is not a cloud, but it is part of one, and we'll talk a little bit about that. I think it's the next slide actually with a picture. So sort of the takeaway here is think of a cloud as a resource pool, right? Compute resources, network resources, storage resource, whatever they might be, that you can access via an API, right? Okay, regions and availability zones. So what we have here is cloud infrastructure provider, and this is going to look a lot sort of like what AWS has mapped out, and for good reason, right? I mean, they've done a good job, and a lot of the other providers, infrastructure providers, are trying to follow something similar to this mapping, right? You notice that I have cloud/region 1. I have cloud/region on all these. Basically, we look at those terms essentially interchangeably. Even though AWS may call them regions, we really think of them as disparate clouds, and we'll talk a little bit about why. Within each of these clouds, you'll see that there's different zones. So you have zone 1A and 1B in both region 1 and region 2. And region 3 has 1A through 1D. It has 4 availability zones, right? The zones within a region share a LAN, and therefore they have high bandwidth, they have low latency, they have private IP access, and generally free or very, very cheap bandwidth costs between them, right? They also utilize separate power resources, and they're physically segregated in different buildings, or at least different floors of different buildings, et cetera, and on different power grids like we talked about. And until recently, we thought they were completely siloed, right? The outage that happened back in April was definitely, I think, an eye-opener to AWS as well, and that particular problem won't happen again, right? They know what they've got, and they fixed that problem accordingly. However, regions, those are islands. They share no resources. So even though AWS may call them regions, we call them clouds. It doesn't matter to us if that's AWS US East and AWS US West, or if that's Rackspace, right? As far as we're concerned, it's a different cloud and has its own associated resources within that cloud, okay? So as such, because they might not all be from the same cloud infrastructure provider, we've got some multi-cloud pain points that we've got to find our way around. So APIs differ, that's first and foremost, right? There's no RFC, there's no standard on how to fire up an M1 large in the cloud. There's no definition of what an M1 large means, right? Everyone can define your own, okay? So there are no RFCs, there are no standards on this right now, so it is sort of a little bit of a free-for-all. There's different formats, encodings, versions of these APIs, et cetera, right? So that's very, very challenging when you are programmatically trying to access these resources. The abstractions and the features differ, right? You've got network architectures that can be different. You've got VLANs, you've got security groups, you might have elastic IPs, you might have access control lists. It's up to the infrastructure provider what they provide to you, right? They may or may not provide the things that you think you need or the things that you've used in other clouds. The storage architectures are going to be different as well, right? You generally have a local disk, right? You may have an attachable disk, the EBS volume concept. You have to do backups and snapshots. They may mean different things in different clouds, right? Hypervisors are different, machine images, et cetera, et cetera. You see it all here, right? All these things are different, and these are all hurdles that you need to overcome. So sort of the takeaway from this one is that you need to think of each cloud as unique in maybe all of the ways, right? Some, many, all of these respects. And the way that you access those features, the access mechanisms and the functionality provided could be very different. So you've got to find a way to work around these issues, right? So those are hurdles. Those are obstacles that we need to navigate over, we need to get past. So what we always recommend to customers is design your architecture using generic concepts. For example, I need durable storage, right? Okay, that's a generic concept. But when it comes time to deploy it in a cloud, use a cloud specific. For example, EBS volumes is my durable storage if I'm in EC2. Maybe if I'm in rack space, it might mean the local disk or something like that. Whatever it means, you need to be able to think generically and implement specifically. You want to have tools that both automate and translate these concepts to cloud specifics. For those of you that are familiar with Chef and the cookbooks and recipes concept, right? You can have a script or a recipe, if you will, that chooses based on the cloud it's on the correct provider, the correct resource, and therefore the correct provider for that resource. So you want to have these automated tools in place that you basically say, I need storage, and that recipe goes out and says, okay, I'm on AWS, that means EBS. Or I'm on Rackspace, that means such and such, okay? So you need to have that automated tools in place to do what you say. You're speaking generically, and they're implementing specifically. And then the hard one, think about how to share resources across the clouds, for example, data sharing. And this is the hardest part, and this is the part we'll talk a little bit about at the end of this presentation as well. So, architectural options and considerations. All right, we're going to talk a little bit about some sort of checklists and some general best practices, and then we'll start to look at some reference architectures, okay? So when customers come to us and ask us for HA solutions, we basically present them a checklist such as this or something very similar, right? The first one, determine who owns the architecture, the disaster recovery process, and the testing. Generally is not, and should not be the same person or group, right? To use a software development analogy, anybody here who's done software development, you know that you probably make the worst tester, right? Because you know how things are supposed to work, so you're not going to try the crazy stuff. You're not going to try the boundary conditions and the edge cases, right? But if you give that to somebody who knows nothing, and they don't know how it's supposed to work, they're going to do all that crazy stuff that you need them to find those problems, right? So it often makes sense to have these responsibilities owned by different people or different groups. You want to develop expertise in-house on DR and HR solutions, or get outside help. And this is the RightScale user conference. I didn't want to do it yesterday so much and pimp RightScale, but I'll do it here a little bit. Obviously, professional services can assist here, right? There are other groups out there if you want to contract with them as well, but if you don't have this expertise, you probably want to find someone that can help you out. You want to conduct a risk assessment for each application. And basically what that means is take a look at each of your applications and figure out how screwed am I if this thing goes down, right? How bad is it if I lose this, okay? And then after you've answered that question, look at each one of those where you answered, I'm really screwed, take a closer look and say, where is this thing very brittle? Where are the tenuous points within this application? And conduct a risk assessment and find out where your brittle points are. You want to specify your RTO and your RPO, and oftentimes those are in direct contrast, right? You might have your time objective might be very, very short. Well, generally that means you might be losing a little bit of data. If you can't lose any data, that might take you a while to get back up and running, right? So it's this constant trade-off between the RPO and the RTO. So you have to figure out what makes sense for you and what makes sense for your customer. You want to design for failure starting with the application architecture, and then that will help drive the infrastructure architecture. Excuse me. One of our customers came to us with they had an application that did single-threaded writes to the database. It didn't matter what architecture we put in place for them, their application wasn't going to be able to take advantage of it. So you need to have an application that can take advantage of the architecture that you're going to map out, okay? And again, I mentioned we're going to have this constant reiteration of balancing cost, complexity, and risk, right? We always recommend you automate the infrastructure for this consistency and reliability. And again, this is where server templates, so if you're familiar with our server template concept, comes into play, right? You want the ability to bring up a server that looks just like the server that failed. You don't want to have Joe bring up a server, log in, do apt-get install Apache 2, modify the HTTP conf file, download a few other packages, whatever, because he's going to screw one of them up. If he has to do it 50 times, he's going to do 49 of them right, and one of them he's going to miss something, right? So you don't want poor Joe to have to do that. You want it automated. You want to be able to click a button, that server comes up and looks just like the one that died, right? You want to document those operational processes when you get them, okay? You're going to go through and figure out how you need to bring yourself back up in the case of a failure, and document that, right? Because this isn't going to fail at 10 a.m. when you've had your cup of coffee and you're ready to go, right? This is going to fail at 2 or 3 in the morning when you're groggy, you don't know what's going on, and you're like, well, what do I do? Well, you want to have that list in front of you that says, step 1, do this, step 2, do that, right? And then once you have that process in place, test that failover. Test it again and again and again. Really try to push the edges, find those boundary conditions, if you will. And then to use a Netflix term, the chaos monkey, right? They have a process they call the chaos monkey that goes around and randomly kills instances and deletes elastic IPs and removes EBS volumes, right? And they do that to make sure that they can survive that, because everything fails all the time and they want to be prepared for that, right? So you need to have a person or a process in place that does something similar. You want to kick out every power cable. You want to spill coffee on the keyboard. You want to push the big red button that says don't push, because if you don't, someone's gonna, and it's better that you find it than you find it as a result of a customer event. A couple architecture deployment options that are pertinent to the slides and the reference architectures that we're going to look at. I'll just kind of briefly touch on these, but DNS. We always recommend to our customers that use some sort of dynamic configuration DNS APIs to allow them to quickly and rapidly reassign IP addresses, right? If you have a front-end load balancer that goes down and you need to bring up another one, you want to be able to quickly map the IP address to this new instance when it comes back up. If you need to promote a slave to a master, you want that slave to be able to assume the identity, if you will, of the original master. And you do that through DNS, and you need that to be a programmatic approach, okay? Load balancing. Probably the 4 most common options that our customers use are the ones you see listed here: HA Proxy, Zeus, AI Cache, and ELB, which is the Elastic Load Balancer, the AWS solution. AI Cache is more of a front-end caching solution, but it also makes a very effective load balancer as well. So those are probably the 4 most common ones. Storage, we talked a little bit about local storage. Generally, with every instance you launch, regardless of the cloud it's in, you'll have local storage. Excuse me, you may have EBS, you may have S3, you may have cloud files, you may have a high-performance distributed file, shared file system like GlusterFS, something like that, right? These are the potential building blocks, and we're talking about a little game of Tetris here. I've got all my pieces. Let me find the best way to put this together, okay? In their server array, you're generally going to have scalable tiers, right? You want to have scalable tiers of both the web and or app tiers. And we always talk about scaling up and down conservatively. And what we mean by that is make sure you have infrastructure in place. Act on trends, not on anomalous or panic conditions, if you will. If you see a trend in activity that things are getting busy, throw some extra infrastructure in place. If you see a long-running trend that things are slowing down, then pull some stuff away. But do it conservatively so that you always make sure you have more than you need. Even if it's 1 or 2 more, what's that, 34 cents if it's an M1 large? That's a small price to pay to have that little extra security, right? Just so you know, too, we also have white papers on both the load balancing concept and the scalable web application. So if you look at our website under white papers or something, you can read more about a lot of gory detail on this, but that's the gist of those 2 topics there. On the database side, we've got a lot of options. MySQL, we recently released Postgres. We've got SQL Server, Amazon's RDS, NoSQL solutions, database sharding. Our folks from Code Futures can help you out with that if need be. All right, so here's a lot of the architectural options that we're going to talk about in the following slide after we talk about the best practices for implementing them, okay? Obviously, the general HA best practice number 1, avoid a single point of failure, right? If you have a single point of failure, you don't have high availability, period, right? It's that simple. So we recommend always place at least one of each component. You'll see the list there: load balancers, app servers, web servers, databases, whatever they are, in multiple AZs. If you lose an AZ, you haven't lost everything, right? To use AWS US East as an example, there's 4 AZs. So if you spread your app servers accordingly and an AZ goes down, you've lost 25% of your infrastructure, not 100 or 50, right? So use those AZs to your benefit. This next one is a great idea, but it costs some money, right? And that is maintain sufficient capacity to absorb cloud failures, availability zone or cloud going down. And I think it's Netflix again, they run something like 3 times the capacity that they really need to support their infrastructure. So what that means is their servers are at most 33% busy, or if you will, 67% idle, right? And why do they do that? If an AZ goes down, they've got enough infrastructure in place to handle everything and still a little bit of room to grow if there's a panic going on or something, right? So not many companies can afford to spend 3 times as much as they need, but if you want a true HA solution, you need to consider these types of things, all right? And a little side note on that one is on reserved instances, right? Those who are familiar with the AWS concept of a reserved instance, you can basically pay it's not necessarily a premium, but you can pay money to have an instance capacity available for you in the case that you need it. So for example, if you are running your entire infrastructure in US East, you can reserve some instances in US West that you're not running. You've paid money ahead of time for them, but you're not running them. And if US East goes down, everybody's going to scramble to bring stuff up in US West, right? Well, you don't really have to scramble as fast as everybody because you have guaranteed capacity, right? Now again, it's that insurance policy we talked about. I'm spending this money for something I hope I never need. So how much am I willing to spend for something I hope I never need, right? We always recommend setting up monitoring and alerting and escalations and remedial actions, right? Find problems before they become problems. Virtually every software package out there is monitorable, right? So monitor it. Take an idea, have a graph, have thresholds set so that if certain funky things start happening, you're alerted to those funky things and you can poke in, maybe log into the server and figure out what's going on before something really bad happens. And then design stateless applications if at all possible, right? So that if an app server does reboot, right, or gets terminated for whatever reason, it's not this horrible end user experience, right? Not every app lends itself to this, but if at all possible. I'd like to talk a little bit about some reference architectures, and what you see here is what we call the multi-availability zone, or the multi-AZ solution. You'll notice that on the left there's region/cloud 1, and on the right it's also region/cloud 1. What's different is that the left side is zone A and the right side is zone B. And if there are multiple zones, for example, US East has A, B, C, and D, the same concept you see here would apply to all. I've just drawn it with 2 to simplify the diagram, okay? But the concept here is, as you see, spread the load, right? Put stuff in both availability zones. So if something bad happens and you lose an AZ, you haven't lost everything, right? So for example, place your slave databases in a different AZ so that if zone A fails, you can promote the slave that's in zone B to master and pick up where you left off. Granted, at a degraded performance like we talked about, right? Fault tolerant. You're going to be degraded, but at least you're not down, okay? You want to take snapshots as frequently as possible, and we'll talk a little bit about the pros and cons of that in a minute, but take those snapshots so that if something bad happens, you can restore yourself within that region. Now, the way that EBS snapshots, you probably are familiar, is that you can take an EBS snapshot and it gets uploaded to S3, but you can't really go to your bucket and see it and copy it around, right? It's there, but you can't get to it, so you can't move it region to region. So that introduces some unique challenges, and we'll talk about that in a minute as well. Consider local storage for the additional slave database, right? So for example, what some of our customers have started thinking about doing now is they'll have a master and they'll have a slave. The master will be running on EBS and the slave will also be running on EBS, and then they'll have another slave that instead of using EBS for its storage is using the local attached ephemeral storage, right? So that if an outage, like April 21st happens again and EBS goes away, well, they've got a slave that could care less. It's got no EBS volumes and it's still up and running. So they promote that slave to master. Things are good. Granted, you probably don't want to run on ephemeral storage for too long, but they wait until the problem settles out in a day or two, and then they recreate their architecture on EBS, right? So, and if there's some outage that takes down all the instance attached storage, I don't think there could be, but I don't know how they have architected, then you're fine against that as well. So you've mitigated your risk in whatever failure case may pop up. And the last point on this slide is we recommend to our customers to consider distributed NoSQL solutions where possible, right? Not every app lends itself to NoSQL, right? You might need, I always think of it should be more like no-rel. It's more of no relational, right, is what you don't really have. If you don't need that relational aspect of your database, look at NoSQL solutions. You can put primary and replica nodes in different AZs and spread the load, and they're self-healing, and they work pretty well. Cassandra Ring is a really, really cool thing if your app can take advantage of a Cassandra Ring, okay? So now I want to digress briefly into DR, and we'll see why, because sort of the DR solution builds up to the grand finale, if you will. So the DR solutions that we talk to customers about, the cold DR, and we'll see what we mean by these. The cold DR is the most common, and the most common for one reason. It's free, basically. Very, very cheap, or basically zero. However, it takes a while to get yourself back up and running. As we move up the graph here, the warm disaster recovery is the one that we recommend to most of our customers. It costs a little bit of extra money, but your downtime is not too bad generally. Then there's a hot DR, which has a very, very short downtime, but it costs a lot of money, and it's not a huge gain over the warm configuration, and we'll see why in a second. And then sort of what we put on here is the multi-cloud HA, which is a multi-cloud high availability solution, which has no downtime, costs a lot, and is super complex to architect, and that's sort of the last thing that we'll talk about, okay? So cold DR, multi-cloud cold DR. So you notice that we have region/cloud 1 on the left and region/cloud 2 on the right. Everything in region/cloud 2 is grayed out for a reason. Nothing there is running, okay? And those of you familiar with the RightScale platform, and the server template methodology, you know that you can basically clone your environment. You could have this environment in region 1, you can clone it, you can move it into region 2 and have it ready to run, but not running, right? And you can then click the launch all button and those servers will come up. Not recommended if rapid recovery is required because it's slow to get that data from cloud 1 to cloud 2, right? And if that's EBS snapshots, you can't even do that. You're going to have to find some other mechanism to do that. For example, LVM snapshots, our latest storage, I think it's called the storage template or storage server template that we just came out with. If you guys were here this morning when Daryl showed the MySQL, basically taking a snapshot of a MySQL running in Rackspace and bringing it up in AWS, that was done using our storage server template, right? That ability, and that's doing LVM snapshots as opposed to EBS snapshots. So, is this doable? Yes, okay, but it takes a while to get yourself back up and running because A, you have to bring all that data over, you have to get your database to an operational state, and then you have to launch all the servers, right? But what's the extra cost? It's zero. None of those servers are running. None of that storage is allocated, right? So it's a free solution. Therefore, it's popular. When folks ask us, what should I do? This is generally what we recommend, and this is what we call our warm solution. We'll call it warm because it's just a little bit more than the cold one, right? We've got one instance running. We've got a slave running in region 2, and it's attached storage, whatever that might be, EBS or local attached or whatever is pertinent for that particular cloud. And what we're doing is we're replicating from the master to that slave. So data is being pushed across the regions to that additional slave. Now what I haven't drawn here is that the assumption again is that this has multiple AZs and you have a slave over here as well. So this is only if this entire region goes down. If you lose an AZ, you do what you always do, right? This is only if the entire region goes down. So now what happens in this case is that the slave database is hopefully not that far behind, right? Replication lag shouldn't be too bad. If it is, you know, you're going to have to find some way to hopefully work around that. Maybe copy bin logs over if you can still get to the master database's storage, perhaps, something like that. But the point is that you can get that slave database up to an operational state relatively quickly, a lot more quickly than in the cold solution. And once it's up and running, then you can go ahead and launch all those servers, right? So it's a relatively inexpensive solution to give you a little bit of a warm fuzzy that you got a disaster recovery in place. All right. One important thing to notice on this graph, on this picture, is the $ there, right? That $ represents you're going region to region, right, or cloud to cloud, right? That's the public internet at that point. Even if you're on AWS East to AWS West, you're on the public internet, and you have the inherent delays and the cost associated with that. So you have to keep that in mind as well. When we set this up in a proof of concept in our virtual lab. What we did is we used compression. We basically compressed that traffic so that we would hopefully keep it down to a minimum amount of traffic going across. Okay? Oh, somebody animated my slides. I forgot that's not there. Okay, so generally recommended DR solution. It does have the minimal additional cost because you are running that extra server, but you can get up pretty quickly, right? So let's compare and contrast this solution, the warm one, to the hot solution. And the hot one looks a lot like the warm one, with the difference being that all the servers are up and running. They're just not doing anything. There's no load being sent to them, right? So what do we have going on here? We're paying for all these instance hours that are doing nothing, right? And what does this gain us over the warm solution? Well, we get up and running a little bit quicker, right? We don't have to wait for these instances to launch. And what does that gain us? Well, in the Linux world, maybe 5, 10, 15 minutes. If it's Windows, maybe 30, right? So that's what you gain for all that cost, okay? And is that really worth it? Well, generally our customers think no, but I'm presenting the options to you guys and let the buyer make the choice, right? And like I said, allows a rapid recovery, but not significantly faster than the warm solution, considering the extra cost that you have to incur. That leads us to multi-cloud HA, and we'll spend the rest of the time sort of talking about this. And this is where this has the maximum additional cost, right? Not only are you running all these servers, right, but you're also paying for all this traffic bouncing back and forth across these regions, and you're paying for all of that, right? So maximum additional cost on this, right? It does provide high availability, but it is pretty complex to set up and manage, and we'll talk about that in the next slide or two. I think I have a couple bullets on that. So it looks similar to AZ, right? If you think about this, and got rid of the region cloud 1, region cloud 2, it looks a lot like the multi-AZ solution, right? And it is. It basically is a similar concept, but it has some very, very different caveats, right? For example, you got to deal with DNS management. All right, that's not so bad. We've got DNS APIs that can do round robin or geo load balancing or whatever it might be. That's a solvable problem. Machine images, they're specific to the cloud, right? If you're running an AMI in US East, you can't run that same AMI in US West. And if you're running an AMI in US East, you certainly can't run that AMI in Rackspace, right? So if you're not using the RightScale platform, and most of you probably are because you're our customers, you know that our MCIs, our multi-cloud images, abstract this out for you. So what we will do is if you use an MCI, it will choose the correct underlying right image for the cloud that you're on. But if you're not using RightScale, you've got to solve that problem, and that's a tough problem to solve. Here's one of the hardest ones. You need to copy or replicate that data, right? You've got to get that data, like we talked about, from region 1 to region 2. And how do you do that, right? You can't do it with EBS snapshots. You can do it with LVM snapshots, right? And maybe that's your best solution in that regard. Or you can do what we talked about before, where you have a master on EBS taking EBS snapshots, you have a slave doing LVM snapshots. Our new storage server template will allow you to take those LVM snapshots. Let's say you're running an EC2. You can take those LVM snapshots and upload them to S3, or you can upload them to cloud files. And vice versa, if you're running in Rackspace, you can take an LVM snapshot and put it in cloud files, or you can put it in S3. And lastly, security is an issue here, right? You're on the public internet, right? You're not on the 10.x network. There's a 10.x network over here in region 1, and there's a 10.x network in region 2, but they ain't the same, right? And therefore, security groups in one region mean nothing to the second region, right? So this is basically all unencrypted traffic. Let's say that you're running SSL termination on your load balancers, and you terminate that SSL session, and now you're going to pass that traffic potentially across the public internet unencrypted to get to your application server. It's not going to be okay, right? And that's a tough problem to solve also. It is solvable. For example, the folks that I think they're speaking today here as well, the folks from Zeus, they have their traffic manager product. And what that allows you to do is you can terminate SSL at the Zeus solution. You can then look at the cookies and figure out who am I supposed to send this to. And let's say I am supposed to send it to the other region. You can then re-encrypt that traffic, send it encrypted across to the other region, and then the app server on the other region needs to do the decryption. So is it doable? Yeah, but there's a lot of extra CPU cycles and latency and all that kind of stuff, right? So a solvable problem, yes. Is it an elegant, wonderful solution? Probably not, right? So with all that said, conclusions. What's best? Well, design for failure. Again, assume everything fails and try to find a way to work around that as best you can. No one size fits all, right? Every application is different. Even the customers that come to us with social games, right? You all might know we're kind of big in the social gaming industry. You have a lot of customers that do that. Even though you might think they're all Flash-based with a PHP server, and yeah, a lot of times that's true, but their database needs might be different, right? Some take advantage of a NoSQL solution. Some need a sharded solution because they have very high intensive database needs. Some need a socket server if they're doing like a virtual room scenario where you need to be able to chat and play with your buddies and that kind of stuff, right? So not every application is the same, and therefore not all the building blocks you have make sense, right? Just because you've got a hammer, everything's not a nail, right? If there's a screw out there, you got to find a screwdriver to help you out, okay? And again, it's always a trade-off between resiliency and cost, right? You know, the balance, that always balancing act, okay? Fortunately, the options that we have in the cloud, like we talked about, are unprecedented, right? You have the ability to globally, make a global redundancy of your application. You can have it running in EC2 US East, and you can have it ready to go in Rackspace somewhere else, or you can have it ready to go in EC2 in Japan, for example, right? The time to access these resources, very, very short, right? Where else could you spin up a server in 5 or 6 minutes, right? And the investment required. When else would you be able to spin up a server for an hour and pay 8 cents or a micro at 2.5 or whatever it is, right? So the capabilities that we now have are astounding compared to where we used to be. So what do we recommend as well? Follow either our high availability checklist or come up with your own, right? Maybe the one we presented here doesn't quite make sense for y'all, but find one that does, right? And follow that checklist, okay? And generally, when folks ask us, even after this AWS outage, what's the recommended solution? Generally, we say, hey, a multi-AZ solution with a solid disaster recovery. For example, multi-AZ with a warm disaster recovery is generally your best solution from a cost and performance standpoint. Now, everything is different, so different applications may warrant different solutions, but 9 times out of 10, this is generally what we recommend, okay?